What the heck, Robert? The answers are on the thing.
There's only odd numbers.
In your book, but in the module.
I don't either. I've never.
What? Y'all, you are literally in. All right, what section are we in? 2.5? So I'm going to keep, see it says 2.1, chapter 2, 2.1. I'm going to keep going until I get to 2.5. Oh, I'm in 2.4 now. Oh, here's 2.5, right? There's exploration 1. I'm looking for 2.5 exercises. There's quick review. Here's 2.5 exercises right here. I just opened it from your file. Okay, well, give me questions about your homework that you need me to answer, and I'll be happy to answer them or work them. This is 28, 29, 32, 46 to 48, and then 1 through 4. Yeah. Yeah. Is 29 what we did? All right, I'll start with 29 and then I'll move over. Yeah, still just asked for 4 also. 4 is a good one. I did want to run through that one start to finish anyway. All right, 29. Find equations for the lines that are tangent and normal to the curve. Y equals square root of 2 cosine. If that smell is too strong for y'all because it smells like it's getting really strong, you can walk over there and cut that little thing off. It's a little wax warmer. It stunk in here whenever I came in this morning. Just turn. It's a light bulb. Look on the cord. Yeah. All right. I've got a point. I need a slope, so I'm going to do derivative, and I'm going to do the derivative at pi over 4, and that's going to give me my slope. So then I'll have a point and slope, right? Right. So derivative. This is just a constant in front, right? That's a coefficient. So I'm going to pull it out front and then do the derivative of cosine. What's the derivative of cosine? Negative sine x. So this is negative root 2 sine x. And now, are y'all okay? And now I plug in pi over 4. Remember the over 4s are where the values are the same. I'm in quadrant 1. What's the sine value at pi over 4? Root 2 over 2. Y'all okay? Are y'all sleepy? Negative 2 over 2, which is negative 1. That is the slope, right? That's all I found is the slope. So now I'm going to take that point that they gave me, which was pi over 4, 1, and I'm just going to plug in point slope. Y minus 1, slope times x. How do I what? Well, what is the sine of pi over 4? Yeah. They gave it to me. They said at the point pi over 4, 1. Okay, what can I do to help y'all memorize the unit circle values, to help you remember them? You said don't give you one on the test? So you can practice, yes.
Like I know it, like not. Well, like.
No, because that's not going to help you memorize it. That's what y'all told me last year. Obviously not. That's the Maybe every day we need a few problems on the board whenever you come up that are just I can do that. Or maybe every day I just randomly ask you certain. Robert, what's the sine of pi over 3? At pi over 3, sine squared of 3 over 2. Whoa, that's not even one of the values that's on there. Give me another one from your homework. What else did y'all say? Number 4? Oh, 46. Multiple choice. Which of the following is an equation of the... Y'all gonna have to do it again here. So, yeah, that's the one we talked about because you had like 1 over, what was it? Cosine x. When will that equal 0? That's the big question because that's what it means. If this is the slope, when will the slope be 0? Well, it can never be 0 because this can never be 0. The only way to make a fraction equal to 0 is if the top is 0. If the bottom goes to 0, which it could, that doesn't make it 0. That makes it undefined. So that's why. All right. A. All right, it says, which of the following is an equation of the tan line to this at x equals pi? So this time I don't have a whole point. I've just got an x value. So I'm going to have to do two things. I'm going to have to find the slope, which I'm going to do by the derivative at pi. But I'm also, to find the point, I'm going to have to do the original at pi. This is going to give me the point. This is going to give me the slope. And then I can plug in point slope form. All right, well, let's do it. Sine of pi plus cosine of pi. So pi, I'm all the way over, 180 degrees over, right? I'm on the x-axis. What's the sine of pi? 0. Sine is my y, right? So that's my height. It has no height. Cosine is my x, -1. So the point that I'm going to use is pi, -1. Is that what you're talking about? How did I know sine of pi and cosine of pi? How did I know what?
No, I figured it out.
You figured what out?
No, I know how you got it. You were just using the circle.
Let's do the derivative. What's the derivative of sine x? Cosine x. What's the derivative of cosine x? Negative sine x. So now I'm going to plug in, are they? Cosine pi minus sine pi. What's the cosine of pi? What's the sine of pi?
0.
Oh, you mean the slope and the point are -1. Is that what you meant? Yes. So now I have y plus 1 equals slope times x minus pi. And if I look at the way that they are formatted, I need to solve it for y and probably distribute that, just because that's the way those answers are. So if I move the -1 and I distribute this, minus x plus pi, that looks like, I hope it looks like a, negative x plus pi minus 1. It would definitely be a non-calculator problem. So. What unit circle thing? Right. But what if it's a like, okay, type in your calculator the sine of pi over 3. Sure. I talked about it, but I didn't do it. When you take the derivative, you get 1 over cosine. The other one, you get 1 over something. But the point is that you can't ever, in order for a fraction to equal 0, it's the top that has to equal 0, not the bottom. 1's never going to be 0. So it has no horizontal. It'll never be 0. So it has no horizontal tangents. That was more of a reasoning one than anything else. There was no one. Yeah. So if your choices were, or let's, all right, so if I have just any fractions, if I have just any, what if you don't have a calculator, Robert?
I'm screwed.
But you at least know enough that you know what it's like, you know one of the values is supposed to be, right? Because you knew to type in square root of 3 over 2 on your calculator. You know it's either a half, a square root of 3 over 2, or a square root of 2 over 2. There's only 3 choices that it can be. Besides 0 and 1, yeah. You just got to figure out which one it is. Square root of 3 over 2, a half, and square root of 2 over 2. These happen at every over 4. Then you just got to decide these. This is bigger than this, so if it goes over further, then the x is the root 3 over 2. If it goes up higher, then the y is. If you can visualize it, that's what I do anyway. I just remember those 3 values. Okay. Avery, because if a over b equals 0, the only way to make this true is if a equals 0, right? Because if b equals 0, that makes it undefined. You can't have a 0 in the bottom. So the only way to make a fraction equal to 0 is if the top equals 0. Well, the top of this one's never going to be 0 because it's a constant. It's 1. So that's why it can't be 0. When is it x times sine of x versus, and what about that? No, this is sine x times sine x. All right, what else on your homework besides number 4?
4.
That's okay, that's all right. All right, let's do number 4 then. Oh. No. I'm in 32. I'm just going to write the equation. I'm not going to put the graph. Are y'all ready for this? I love these. I know, I'm sorry. Because watch how much fun this is. I need the tangent at P, which is pi over 4. And I need the horizontal tangent at Q, and I have no information for Q. But knowing that it's a horizontal tangent gives me information in and of itself. What's that information? If I tell you something, what equals 0? Derivative. The slope is 0, which means the derivative is 0, right? So if I can find where that happens, then I can also find that point. All right, so let's take it a piece at a time. Let's do part A. I think part A was the easiest one. B was where we got in the rabbit hole. Is that right? All right. So first thing I'm going to do is the derivative, which I will also use for part B. So let's just go ahead and do it. Derivative of 1, nothing. Derivative of square root of 2 cosecant x. Square root of 2 I can take out, that's in the front. What's the derivative of cosecant x? And if you didn't remember, you could change it to 1 over sine x if you were in a situation. Then you could do the quotient. Negative cosecant x cotangent x. So I'm just going to clean this up a bit before I plug in. Cosecant x, cotangent x. And I need to evaluate when x is pi over 4. Now, here again, Robert, I'm at pi over 4, so that means my values are the same, right? It's that one that has the same coordinates, root 2 over 2, because it's an over 4. You can just figure out what quadrant you're in as to if it's positive or negative. This one's easy because it's quadrant 1, so everything's positive. If they're any just pi over something and there's nothing hooked with the pi, you're in quadrant 1. Like if you look at your... Well, yeah, some of them have, but for this one...
Oh, pi.
Yes, 7 pi over 4 is there. You're talking about recently? No, you haven't in your homework yet. Yeah. It just changes the sign. That's exactly right. You just have to figure out where it is and if it's positive or negative. All right. So let's plug in. Negative root 2, cosecant pi over 4, cotangent pi over 4. That is the derivative.
I thought it was inverse.
Well, so it is. It's 1 over sine x, or I can think about it really as just flip sine, flip tangent. What? I did. What's the derivative of cotangent? Sorry. Are you embarrassed for me? It's okay, I'm not embarrassed. You can be embarrassed for me. Negative cosecant squared pi over 4. So this one I'm going to flip sine and then square it. So if I find the sine of pi over 4 and then flip it, that's cosecant. So at pi over 4, here's pi over 4, right? Root 2 over 2, root 2 over 2. So what's the sine of pi over 4? Root 2 over 2. So if I flip that over, in other words, what is the cosecant of pi over 4? And if I rationalize that, make it a little bit better to work with. Why?
All right. Well, I was going to say the square root.
So it's just square root of 2. Everybody agree? Are y'all okay? Where?
Why are you doing that?
Well, it was negative cosecant, so I made it minus. And then this was negative, so I just put the negative in front since this was multiplied. Yeah. So this is going to be negative square root of 2. This is going to be square root of 2. Cotangent of pi over 4. Well, if these are the same and tangent divides sine divided by cosine, then what's the tangent? 1. You're dividing something by itself, right? The tangent's 1. If the tangent's 1, what's the flip of 1? 1. So the cotangent of pi over 4 is just 1. Go with me? We've already found the sine of pi over 4. right? The sine of pi over 4 is square root of 2 over 2. The cosecant of that we found to be square root of 2, right? Right, Robert? So now, why are you staring at me like that? So now I'm just going to square it. So it's 2. Negative root 2 times root 2 is negative 2 minus 2. So it's negative 4. Holy cow, have I answered the question yet? No.
No, I've got no, yeah. No, you haven't.
What did I just find? The slope of the tan line at pi over 4. Now I've got the slope and the point. Now I can write the equation. I had already found cosecant. Remember, cosecant squared is the same thing as cosecant. So y minus 4 equals my brand new slope times x minus, what was my x value there? 5. There's my tan line. Wait till you see part B. That was the easy one. Tell me, all of it? Same thing. So the tangent, the tan line is the equation of the tangent. That doesn't make sense to you? Oh, I see what you're saying, that there's a tangent, there's a tan of this, there's a tangent value for. I see what you're saying. I understand. I understand. Yeah, I get that. I know what you're with you now. I'm tracking. All right, let's set the derivative equal to 0. We already found the derivative. I'm not going to rework that. So I'm going to take this derivative and I'm going to set it equal to 0. Here's where it gets tough. Because that was a weird comment to make about calculus. Let's do this spicy problem here. Now we're finding when the derivative equals 0. So we can find out where because for this one, remember I need a point and a slope. I have the slope, I need the point. So in order to find the point, I need to know where is this happening. So if I set the slope equal to 0, it'll tell me what x values that happens. Okay. All right. Who sees anything at all that I could do here? No. We've already taken the derivative. We took the derivative. I just pulled it from part A because I'd already done it. I would definitely factor something out here. Tell me what you're thinking you should factor. The cosecant. I would take out a cosecant. And let's see what happens. And it could be that you look at a problem like this and you just don't even know which way to go. You do something, it doesn't work. You do something else, it does work. So it's just kind of, let's think about what we can do and see. That would leave negative root 2 cotangent x minus cosecant x. Think about that zero product property. No, it wouldn't matter if you want to take out negative. Remember that zero product property we learned in Algebra 2? If two things multiply to give you 0, one or both of them has to be 0, right? Remember when we were factoring and we set each piece to 0? This is cosecant times this, and here's all this. So what I could say is, where does this equal 0? And now where does this equal 0? Everybody okay there? Either of those would make my equation true, yes? If this was 0, 0 times anything is 0. And then if this was 0, then 0 times anything would give me 0. Either of those would work. Right. Or Divide both sides by cosecant x. Okay. Okay, so this goes back to that number 28 we were looking at. I took out a cosecant and one of these cosecants. Negative 1 over sine x equals 0. What does x equal? That doesn't work. Why does that not work? Look at you. That can never be 0.
Oh.
The top is, that's exactly right. If it was flipped, I could do it, but because it's, yeah, okay. No, it's not going to work. 1 over 0 is undefined. It's not 0. 0 is different than undefined.
All right, so the answer is what? Not 0.
So there's no solution. There's no solution for this part, so I don't have to worry about it. So the only way this equation is going to be true is if this piece equals 0. Because that first piece is never going to equal 0. Okay? All right. So, ideas, thoughts. Change what? That's exactly what I would do. I think that's what you were trying to say. I would definitely try, always, if you ever get stuck on trig, try to take it back to basic trig, sine, cosine, tangent. Everything can be rewritten with sine, cosine, tangent, okay? It just might help you. So I got square root of 2, then I got cosine x over sine x, because that's cotangent, right? Plus 1 over, oh, what do you notice? You can combine them. You can put them together. So this is really like square root of 2 times cosine. I can put that on the top with it, right? And maybe you did before. Yeah, because it's multiplied. Top times top, bottom times bottom. So if I put these together now, I've got square root of 2 cosine x plus 1. Everybody goes over the common denominator. Robert wanted to take a negative out in the beginning. Okay, now what? I've got a fraction equal to 0. This has been a common theme today for some reason.
Oh, it's never going to work.
What's never going to work? Oh my gosh. Oh.
Wait, look, I don't think it will ever work.
What regular algebra do you do? Okay, so if you did that, what good is it going to do you? Like if I did square root of 2 cosine x plus 1 equals sine x, what good does that do? What equals 0?
On the right side, and then minus 1, minus 1.
Okay, y'all are just going about it way hard. What is the only way that a fraction will equal 0? If the top equals 0. That's what I'm saying, but y'all went like way around. But yes, yeah. Wait, now if you times sine x on both sides. Oh, I see what you're saying. Okay. Okay. Subtract 1. No, you can still do it. Go. What else? Yeah?
Oh, wait, we're going to get
This does not look like something I'm familiar with, but if I rationalize it, tell me, Robert, what exactly you are trying to type into the calculator.
Yeah, I realize it won't work.
Yeah, right. But if you know your unit circle,
I know where that is.
do you? Where is that?
On
Okay, so my cosine is negative, which puts me on the left side of the unit circle, right? I'm either in quadrant 2 or quadrant 3. Yes. So that's your answer, 3 pi over 4. How do you know it's not? Because if you look on your unit circle, there's two places where it's negative, right? 3 pi over 4 and 5 pi over 4 both have negative cosines. How do you know it's not 5 pi over 4? Look at your graph. Look at that graph. X is only going between 0 and 3, right? If you look at where Q is a little past 2, right? That's the biggest it could possibly be. Okay, just go 3 pi over 4. Now, that's still not the answer to the question. Look at your domain restriction, right? The domain on this one doesn't go past 3, right? So where is 3? Well, what is pi? What's the value of pi? 3.14. If you go past pi, you're too big. Okay. Right. Okay. Now that's still not the answer to the question. That is the x value of point Q. What did it ask me for? The horizontal tangent. So this means remember, for an equation of a line, I need a point and a slope. I have a slope and a half a point. How do I find the other half the point? Plug it in what? The OG equation. Y equals 1 plus root 2 cosecant 3 pi over 4 plus cotangent 3 pi over 4. We're already at 3 pi over 4. We already found that we know the cosine value, right? Because that's how we got this. So that means the sine value here, remember this is flip sine, this is flip tan. What's the sine value at 3 pi over 4? Your unit circle. 3 pi over 4. Square root 2 over 2. Now flip it. Is it positive or negative, the sign? You only flip it over. You don't change the sign. Just flip it over for the cosecant. You're thinking cosine, I think. But all right, if I do this, I get 2 root 2 over 2, which again is square root of 2. Plus, what's the tangent at 3 pi over 4? Negative 1. Flip negative 1 over. Negative 1. I get 1 plus 2 minus 1, which is, now what did it ask me for? An equation. Not just a y value. Why is the y value so important here? What kind of equation? The tan line, what kind of tan line? Horizontal tan line. How do you write the equation of a horizontal line?
That whole time, all you need was that.
Wait, why can't you write it like a
Well, you could, but what's the slope? Okay, so the point is, so y minus 2 equals, the slope is 0, x minus 3 pi over 4. You'd get y minus 2 equals 0. They gave us the slope for the tan line. Well, they said it's horizontal tangent. For part A or part B? Yeah. Part A, we had to find the slope at that point, but part B, we just set the derivative equal to 0. Yeah. Yeah. If the line, this is actually good practice for us for our test, so I'm okay with these because remember your test is Thursday. If the line tangent to the graph of the function f at the point 1, 6 passes through the point -1, -4, so we're tangent at 1, 6 and passes, no, line tangent to the graph of the function f, yeah, and passes through the point -1, -4, then f prime of what? Of 1 is, okay, so f prime of 1 tells me the slope of the tan line at x equals 1. Do you agree with that? The point of tangency is 1, 6. Agree with that? What is this? What is that they're giving me? A random point on the tangent line. Find the slope, a rock, right? Because the slope of the tan line is the derivative at that point. Whoa. -4 minus 6 over -1 minus -10 over -2. So, Robert, how'd you know to do that? I know. How'd you know to do that? All right, let's run through number 4 because that's the one I really wanted to get to. 5. Particle. Huh? Well, I don't actually review you. I just give problems. You're welcome. Yeah. Today and tomorrow. Test it until Thursday. A particle moves along the line so that it's positioned at any time. Here we go. Back to this crap. This crap never goes away. S is measured in meters. T is measured in seconds. What's the initial position of the particle? How do you find initial position? What does that mean? Plug in 0 for what? Position tells me use the S, right? Initial means there's no time, so I'm really just finding S of 0. There's 2 seconds. Yes, meters, sorry. I know, so embarrassing, isn't it? I embarrass you. My teacher's an idiot. She can't even get the units right. It's okay. Find the initial, why? Find the initial velocity of the particle at any time. Well, because you can't hear y'all talking.
It's so funny that you're funny.
Oh my gosh. All right, how do I find velocity at any time? There's the derivative. That's right. What are the units for that, by the way? Nice, nice. Yes. Faux show. Faux show. You will have one. How you say it then? Y'all are just eating me alive today. Huh? No, I'm not trying again. When's it moving to the right? Don't do that again. Don't do that. That makes me uncomfortable, Robert, and I don't like it. Sine analysis. That's exactly right. I'm going to see when does the velocity equal 0? Because Robert keeps weirdly winking at me while we're doing the lesson, and it's making me uncomfortable. Well, they'll all know what a weirdo Robert is then. Okay, so if t is where it's 0, right? So 1/2. The velocity is going to tell me what the position is doing. Because Velocity, when it's positive, she's exactly right. When it's positive, it's moving right. When it's negative, it's moving left. Position just tells you where on the ruler it is. So it doesn't matter if it's positive or negative. What if it started negative? Well, here it started at 2, right? So if I plugged in a time and I got position was 1, it would look like it moved forward because it's positive, but it really didn't. It moved backwards because it started at 2. Does that make sense? So we have to look at velocity to tell which direction it's moving. All right, so I'm not going to go past 0, right? Because we don't travel backwards in time. So in between 0 and a half, what is my sign going to be? And I'm looking at the velocity equation. Positive or negative? Y'all sure? But put like 1/4 in. So negative a half plus 1 is positive. Right? Well, no, because at 0, probably not. Okay, it's just cut off at 0, but how about past 1/2? So if I plug in like 2, it's negative. So it's moving down or left, right? Those are the same thing. So where is it moving right? It's moving right from 0 to 2. Oh, second. There's plenty. Because asking when is it moving to the right? It's moving to the right here. And velocity, yeah. Yeah, because it's asking when, so you would have to, so the first half a second it moves forward. Then after that it stops and it moves backwards. Yes, it is. Well, they are, but you're not asking how many meters does he move before. Now, you could plug in a half and find out where he was on the ruler then. But when you're talking about when, you're talking about seconds. You're talking about how long did he move for that time period. Because this, when you solved it for t. And t is in seconds. And you're plugging in for t. When's it moving to the right? Oh, we already did that. I thought that was okay. When's it moving to the? Oh, it doesn't ask for the left. Okay. Jeez, what's the acceleration at any time? Constant acceleration, right? Meters per second squared. Then it asks for the speed of the particle when the position is 0. So 2 parts here. When is the position 0? At 2, right? So I'm looking for speed. Speed is absolute value of velocity. So I want the absolute value of velocity when the time is 2. Negative 2 times 2 plus 1. Negative 4 plus 1, which is, what does that tell me? 3 what? The speed, meters per second. My bug is traveling at 3 meters per second initially. Yes. Oh, that was an E, sorry. Because it asked me the speed of the particle at the moment when S of t. Oh, no, this is initial. That's right. We did it wrong, though. It doesn't say at initial, yes, it doesn't say at initial position. It says when S of t equals 0. Well, when does S of t equal 0? Not when t is 0, but when S of t is 0. For whatever reason, I think we get the same answer, but that was just a fluke. So that's right. Did you figure that out all by yourself? That's impressive. T squared minus t minus 2, I'd have to factor. t minus 2t plus 1. So when is position 0? Well, when at 2 seconds and negative 1 seconds. Well, again, we don't travel back in time, so that makes no sense. That's not in our domain. So 2 seconds is what which happens to also be the initial position. That's why it works. Yeah, take a break in between, and I'll get your problems together. 154 to 157. Yeah, go ahead. This is all we will do in class tomorrow also. And you'll have homework. I won't have time to answer questions on Thursday, though. So tomorrow's the only day I'll have to answer questions. And I'll be up here the whole time answering any questions you have. So make sure you look at least all of them, even if you don't have time to get to them. You won't have time to get to all of them. Let's do 3. Okay, I've got these written down somewhere. I've got to make sure I include the ones that this was supposed to be. Remember, this is 2 nights before you'll start. This will look like a whole lot. I know, but I'm trying to pick practice problems that look like the ones in the test. That's not all. Some of them are quick. Some of them take a little longer. There's 4 more, just wait. It looks like a lot because I actually wrote them all out, y'all. Okay, well, last year these were all the ones I did for 1 night's worth of review, and we used the class to do it. Y'all got 2 nights this